right, welcome everybody. Welcome to our second edition of Process Mining Café. We're here today. We have a guest again. Today our guest is Professor Hajo Reijers. He's a full professor for process management and analytics at Utrecht University. And we interviewed you on our blog more than 10 years ago, Hajo. So it's high time that we catch up. But before we do that, we want to do a little bit of follow-up from the last Process Mining Café. So some of you have joined us the last Process Mining Café more or less 1 month ago, where we talked about data requirements for new IT systems. And we received some comments and some questions afterwards. We thought it would be nice to also briefly address them here today in the second edition of Process Mining Café before we start and go more into the discussion with Hajo about process mining and research and how they connect and intersect with each other. So, talking about the process mining data requirements last time, one of the important requirements that we mentioned was that you need a start and a complete event timestamp to measure the durations of activities, right? So here I just brought up Disco again to remind you of this point. So when you have both a start and a complete timestamp, this means that you can differentiate the activities in the process and how long they take actively from the waiting time or idle time in between activities in the process. And so this is important, for example, to perform cost analysis, because you can determine how long the activities are taking, and combining this with resource costs, for example, you can make a cost analysis. So this is really important for service processes in particular. But for example, for production processes, often another metric is important, for which you also need start and complete timestamps, which is utilization metrics. So I'm curious, Hajo, do you also sometimes work with utilization in your research?
Yes, definitely, because utilization is a very important aspect to understand, well, how much capacity of workforce you have available to complete things. And as we know from, for example, queuing theory, we know that waiting time has an immense effect on cycle time and throughput times in processes. So often you have to have an accurate understanding of utilization of your workforce to make accurate predictions of when work will be completed. So indeed, that is an important element.
Yes, okay, yes, absolutely. So you're completely right. For workforce planning, that's also really important. Another example would be the whole production process environment. People have machines, for example, right? The machines are already there. So what they usually want to make use of these machines as much as possible. So the utilization should be as high as it can be. So I just briefly wanted to show you also where you can see this and look at the utilization in Disco. So for example, here in the overview statistics, you actually have, if your data set has start and complete timestamps, so like we discussed, this is needed to separate the active and the waiting time, you can see the utilization statistics over here. So for example, for this data set, you can see that there's one case at least who has up to 40% utilization, and this means this is the ratio of active time compared to the whole time of the full case, right? So 40% means 40% of the time in the case has been spent in activities actively, and the rest 60% is waiting time. You can also see this for each case here. For example, this particular case has 70% active time, so 17% has been spent time in activities and so forth. Now, for a production process, this would be actually really bad, right? Because 40% utilization, that wouldn't be really good. And so what you can also do is you can filter. And so, for example, in the performance filter, you can, if these would be all machines for which you wanted to find the ones that have a good or a bad utilization, you cannot just filter based on case duration, which is the default, but for example, based on case utilization, you could, filter all the ones that are below a certain utilization threshold. And that just as a tip that I wanted to give. And then the last point I wanted to make is to remind you that you can also take different perspectives on the process that you're analyzing. And for example, if you're looking at a production process where you have certain parts that are being processed, usually how you write the first case that you would choose for that would be kind of the material number or the product number. That would be the case. But if you're looking from a machine perspective or machine utilization perspective, you can actually make the machine the case. So for example, if now this is not a production process, but here, for example, we have different roles. So these are the departments or the teams, or let's say departments in this service process. But if you imagine these are the 5 machines that we have in a production process, if we are interested in looking at the utilization per machine, what we can do is that we, in the import step, that we actually changing the view on the process by not using the product or material ID as the case, as we have done here, but essentially taking the machine, let's say this is the machine now, as our case. And once we import the process again, we will see the process show up per machine a little bit. The process map looks different, but also here, if we're looking at the cases, we have now just 5 cases. And in the cases view, we can then, for example, see, what the utilization is for each of these machines. And we can, again, use the filter to filter the ones that have a low utilization and analyze them further. So that's just as an addition that I wanted to give on your way based on the feedback that we received after the last cafe for mostly production-based processes. The second point of follow-up that I just briefly wanted to make is that Jan Hendrik, he made a comment, and he said that sometimes he has to advise customers how they can improve their data. So again, that's the situation that we talked about last time. And he was wondering how he should recommend them that they change the data if they have to do it manually. So for example, if you can build into the system a way to record the start timestamp, not just the completion, but if employees have to do it manually each time, is that a good idea or not, right? You want to have more data, but Hajo, I think we will come back to the topic of data quality a little bit more. As soon as you ask people to do something manually, it's going to be a problem, right?
Yeah. I certainly agree.
So even if they want to do it right, you have to, I think, in this situation, think about whether it's worth the benefit that you get, whether it's worth the extra work that they have. It's usually fine to manually collect data for a matter of weeks for a limited time to gain some insight. But if you're requiring this on an ongoing basis continuously, I think that's a different story. Think about whether that's really needed, and maybe a solution that we thought out together a little bit could be that if the employees already log the completion of an activity, maybe you could ask them to log the time that they have taken to complete this task, and then based on this time you can calculate the start timestamp. So that reduces the load of manual logging for them from logging it twice to just logging it once, and in this way you still can get better data. So that would be my recommendation for this. All right, so this was a little bit of follow-up for the last Process Mining Café. So let's dive into process mining research, Hajo. We're really happy to have you here. So maybe let's start by please introduce yourself a little bit. What's your background, and also specifically, what have you done with process mining so far?
Yes, so I have a background in computer science. I studied computer science in Eindhoven. I worked for a number of years as a consultant, and typically in IT projects where we implemented workflow management systems, business process management systems. So that was the time that I really became interested in processes. And only after some time that I worked in industry, I moved back to the university to do a PhD project. And the PhD project at that time was already focused on business processes, or workflows, as we also often refer to them. And what I learned, what I started learning about myself when I got involved in research, is that I had a lot of training in the algorithmic side of doing research, so developing algorithms and programming and these parts. But since my interest moved to these processes, there was this terrible thing that happened. You had to interact with people, right? And that's a very scary thing for many computer scientists. And I noticed that this was an area where, for my training, I didn't know that much about, for example, how to, we just talked about measuring things in the real life, how to really set up sort of a measurement program. Or if you think of developing a new method or a new IT system, if you want to know how effective it is, you have to get involved into experiments, perhaps interviewing people, surveying these things. And so over time, I got to understand that even though with a solid background in computer science, you need additional skills and additional things to do research properly in this area. And I think if I look back at my career, I think I have been working for quite a number of years to also develop this empirical side of doing research much more, which is funny because this is if you compare it with the development of process mining is making a sort of a similar contribution to what I would consider the traditional field of workflow analysis and workflow modeling, which are much more of a design-oriented trade. But process mining is indeed also adding this empirical perspective. It's taking real data into account, and it's really using the real world as a source of inspiration of, well, designing and developing things. So in that sense, my career and also my own development moved hand in hand, I think, also with the advent and development of process mining. So one of my supervisors and one of my academic heroes is Wil van der Aalst. So you cannot work with Wil van der Aalst for more than 20 years without picking up anything about process mining. So that was, of course, he's such an inspiring professor, and he was so much involved in this idea of process mining that I picked up many of the things that he was working on, but where he has always had this very algorithmic focus on developing new algorithms. I have always, from the start, been more interested in the application of process mining to understand organizations better, and also as a sort of a basis to improve things and to redesign things. So my academic love has always been with trying to change things within organizations. But of course, process mining was a very welcome source of information to do that properly.
Yes, no, that fits really, really nicely together, absolutely. And I very much, connected to what you said in the beginning about that you're working on these workflow systems and, maybe with an algorithmic approach or a way of thinking, very much coming from a computer science perspective. But essentially, processes are about people. And that's something that I think also in the very early days, I remember when it was still called workflow mining, right? Process mining was called workflow mining in the beginning. But one of the questions, and that when we talk to people in at companies, for example, industry partners, and we were working on the research side, people were often confused, like, well, why would you want to do something like process mining? Because the process is in the system, right? So the workflow system is executing the process. So the process is automated. So it's fixed, right? So the imagination was that the process is fixed, and why would you want to analyze it? It's clear it has been modeled or designed.
Exactly. I have said the same thing when Wil van der Aalst, I think it was in 1999 or 1998, when he first started explaining me the idea. I said the same thing. I said, but Wil, the process has already been modeled. Why do you want to discover it, right? So I also come from that background. But of course, that it has, over the years, it has become so clear that things do not go exactly in the same way as you have modeled them or have intended them. People. All kind of things happen, unforeseen situations, and also processes evolve, right? So even though it is modeled once, it is updated and it is changed. So what is the model situation, right? That's something which is very dynamic, and people have very unpredictable behavior. And I think we get to that later on during the cafe. That they may seem to be doing something, but may actually be something else. And you don't without understanding behavior of people, especially in an organizational setting, I don't think you can do proper process analysis or process design.
Exactly. Yes, it's all about people, right?
Yeah.
Yes, I think maybe one of the first or one of the easy examples, right, to explain it if someone still thinks like, well, the process is automated, or why should it be? How can it be even different from what has been programmed in the system? I think even for a standard process, like for example, if you're looking at an SAP purchasing process, Mieke Jans once made a nice analysis from an auditing use case where they were looking at the process at a big bank, and they were taking the modeled process as a reference to see how much did the actual process, differ from how the process should be. Yeah. And one of the very first things that was just not in the modeled process or in the designed process was make a change the purchase order. I mean, that's something, of course, that happens very frequently, that you have to update something that you didn't have the full information in the beginning, and so it goes, right? And then you get into rework and all kinds of things. But
and sometimes even the process happens as it is modeled, but then for example, the timing behavior is completely surprising. I remember that when we used process mining in a setting of a municipality, when we studied the same process for different Dutch municipalities, we were very surprised that even though the steps in the process were as they were modeled, that the timing of these things were completely surprising. So I think many people who have done process mining have seen, for example, that a lot of things happen on Friday afternoon around 4:00.
Yes.
Right? Then all of a sudden there is a lot of completions of tasks and things which are pushed through. But that also means that people probably do not follow, but they may follow the steps, but the recording of what they really do during the week is different than when you just observe the data, right? People have been working on these things, but only at the end of the week they think, oh yeah, we have to sign all these things off, right? So the order is the same, but the timing is totally different than what you expect.
Exactly. So that's like an additional challenge then, if the data maybe doesn't reflect what people are doing, right? But even if we take that aside and say the data reflects exactly what people are doing, you're completely right. People are working differently over the time or of the week, or different people work differently, and we will come back to this more. But for example, that's one of the reasons why it's so difficult to simulate processes or to create simulation models if you want to simulate behavior, right? So in some of the research that we looked at, and I remember there was this one paper of Joyce Natakumba that she worked on with Will, where she tried to incorporate the fact that if people get more work, that they work faster, right? Yeah, because they want to complete it. But at a certain point in time, it breaks down, because then, maybe you're overworked and not doing anything.
This is in first U-shape, indeed. Yeah. And I think many people recognize it also when deadlines approach, right?
Yes.
When deadlines are approaching, people also become much more efficient, and this is, or they leave out particular tasks to just be able to finish, right? And these dynamic effects are very difficult to capture.
Yes, exactly. So this is, so here we are talking about the processes themselves and how people in them, let's say, influence them and change them. But also I think, that's like you mentioned already, that you like empirical research, right? And that's also something that I have seen from you, that you're a researcher who does not shy away from empirical research, but also is interested in research methods where you are trying to capture this human element in ways that, of course, is much very, very different from thinking about it like an algorithm, right? You have to capture it in different ways. Maybe can you talk a little bit about what maybe the main fields in empirical research or the main approaches here are, and what is important to do it right?
Yeah. So when as I told you, I have also developed myself as a complete amateur in this field. I learned a lot from colleagues, especially colleagues from software engineering, who were much more accustomed to already doing empirical research in how people, for example, produce software. So one of the things that I really was interested in for quite some time is how people develop process maps or process models. And we were investigating. That was also a time that I worked very closely with Jan Mentling, a colleague who's now working in Vienna at the Utrecht University. We were very interested in how people create these models and also make sense of these models. So, because I was a complete amateur, I thought that the experiment, for example, was the most convenient way of testing under certain circumstances what the most important elements were. But over time, I found out that often a very more effective method or technique is to let people think out or speak out their thoughts, so that they tell what they are doing. So you don't not just observing them, but they tell you what they do, and that gives so much insights on how they what they do. For example, when they read a process model, when they tell you where they start in the process model, or what their assumptions are, or what their work hypotheses are, this really helps to understand what attracts them, and what in a process model, for example, is to them important, and perhaps what shouldn't be so important, right? And this is a fairly easy technique to let people say out loud what they think, and this has brought us a lot. And this is often a way also to formulate things which you may later on test in experiments.
That's interesting. That's a really interesting technique, I think. And it seems to me that you're very close to the person you're working with in this way. And I think that's one of the drawbacks of surveys, right? So, for example, I was when I was a PhD, I was working in a research project where multidisciplinary teams were working on different aspects on the project. And one of the people in the other groups, they were working also more empirically, and they were doing surveys, and they were very meticulous about how to design the survey, how to do it right. There were very clear standards about how to do this well. And so, that's one thing that I observed over there, but I also experienced it the other way around, because what I see is that especially like master students, for example, when they come up with, or they need to come up with an idea about a thesis topic, it's very easy to come up with the idea, let's do a survey, about some kind of... I
think that is an overused instrument, because it's in a sense very superficial and not very contextual.
Yes.
While looking at, simply observing experts, that is very difficult to make sense what they do. But letting the experts explain what they do, that is very attractive. Another thing, and that is in the same line, another thing that I grew fond of, and that is also research that I've done together with, for example, with Barbara Weber, is to use very precise measurement instruments to see what people focus on. So, for example, eye tracking devices, so that you can see when people perform work, for example, they inspect a process model or process analysis results, that you can really see through the tracking software what they focus on. Which elements of a graph they look at, and how much time they spend on that, and how their gaze moves through the data analysis. That's a very accurate and also a reliable way to see what is actually making sense for people, what they find important. And that clearly, of course, requires sophisticated devices to do that. But it's in the similar vein that you want to understand what people really are doing.
Yes. Okay, that's great. Do you have any tips for maybe researchers who might be watching this and might be also interested in doing something with empirical research, and they're new to the topic, where they should start, or how they
so
can
I think my most important recommendation is to look in other fields what has already been done. So I mentioned that software engineering, there are very good books on empirical software engineering, and also empirical research and software engineering. So there you learn, or there you can read about, for example, experiments, but also surveys and observations. I think that's a book by Wolin, for example, which I can really recommend. But before you do anything really, as you also said, something very rigorous, or which takes a lot of time to develop or to design, first do a sort of a preliminary test of your ideas. So I myself, I have to admit it, I developed experiments also with my students, which took a lot of time to prepare them. Then we did the experiment, and then we found no effect of the things that we thought were cool. For example, we worked with people and very interesting new modeling paradigms, and we thought, okay, if we give them extra support, they can create better models. And the idea was great, but if we would have asked the people involved rather what they find important and what they use as background information to make modeling decisions, we would have developed another experiment. So before you waste your time, you have to get to know the methods, the research methods, but before you do anything very involved or very complex, try to use it, test it in a simple way. Yeah. Let people speak out loud, observe what they do. That's often not a very big effort, but very insightful.
Yeah, no, that sounds seems like a very good tip. It's like in process mining also, right? It's always a good idea to test a small sample first before you take the huge data set. Yeah. So that's that makes sense. Let me just check, because we have we're live, we're live for a reason. We want to have the possibility to talk with people and to be in contact with all of you, not just listening. So let me just check whether there's any question that we can already address. Let me just read it out, and we can see whether we can answer it or not. So Jeroen asks, Will van Aals posted recently a short article for a new process mining technique, specifically for SAP data, and he thinks that SAP is has standardized workflow steps, and therefore, why would you be using process mining? It's funny, because it's exactly what we've been talking before, right? And it's true, there's standardized processes, but so maybe I can answer that right away, Jeroen. That's exactly the example of the purchasing process, where maybe you design the process for everything goes right, but then once you make a change, there could be rework. Sometimes people do not go through the required, or let's say the ideal process. Systems actually have to give people more flexibility than maybe as the process designer you would like to allow them, right? As a process designer, that's what we also see. Sometimes people, maybe they have the ideal process in mind, but the problem is if you fix that process in the system so much that maybe the system would allow that to do it in this very fixed way, but people have to be flexible to do things differently. Maybe they have to adjust a little bit for a particular customer, or they have to be able to make exceptions. Otherwise, what happens is they will work around the system.
Absolutely. Yeah. People are extremely creative also even if you think that you fix the system and you make it watertight, yes. And they will find ways to work around the system. It's perhaps we get to it, but it's in fact one of the major research themes in my group in Utrecht, to look at how people work around systems.
Yes.
And given the insights we get from that research, that it's so frequent. People use and misuse systems, and you cannot blame them. I think we can all recognize that there are so many IT systems which are poorly designed, or which are designed properly for one particular situation, or for common case, but not for the exceptions, or not for all the different situations that exist, or perhaps they're suitable at one time, but when the rules change or when the context changes, they're not suitable anymore. So I also think it's a complete. I think it's hubris also for IT system designers, that you can design the perfect system and can completely think out what people want to do and how they will do it with the system, you need, and that is what you mentioned, you will also always need some flexibility. But as soon as you have flexibility, it also means variability, right? People will do different things.
Yes, exactly. No, you're completely right. And actually the same principle applies there also when new systems are introduced. I've seen this with some, for example, government agencies, that when they were rolling out a new system, the people who are designing the new system, they recognize that they are not the domain experts themselves. So they have to work with the business units and the people who ultimately have to use the system. And they can do all the requirements engineering and definitions that they want, but there's always the risk that something is missing or isn't completely capturing the way that they need to work. So often they also start small by letting the new system in some kind of pilot mode and then analyzing and evaluating. Does it actually?
Well, we've done at the time I was so I'm still working in Eindhoven University, but when I was working there full time, we did a big empirical research project into the use of business process management systems. So the modern name for workflow management systems, and we looked at the implementation success of these systems. And what we found is that one of the most important factors into what determined the success rates of these projects, and they were very complex IT systems that had to be implemented in organizations. The most important factor that predicted success was whether there was good follow-up after the systems went live.
Yeah.
Whether the people who had to work with these systems were properly supported immediately after going live to take care of all kinds of unforeseen things that the system designers didn't think of, or that they thought of but misunderstood.
Yeah.
And we could see that if you could immediately follow up with the users, the new users of these systems, and solve their issues, and they were often not very complex issues, but the thing is, if somebody who is working on his or her complete working day on something which keeps on annoying somebody because it is the wrong order of doing things, or it will take additional work every time. If you let this exist for a couple of days or a couple of weeks, that's, I think, the bomb under the whole system. So this follow-up is a success factor, and it is completely connected to the fact that you cannot foresee everything as a system developer.
Yeah, exactly. Yeah, and it's about expectation management, right? So understanding from the beginning that most likely you won't be fully there or finished once the system goes live, but building in this as a planned part of the whole project to actually have these adjustments and get it right.
Yeah.
Okay. Let me just see. We have another question from Uriel. So the question is how to combine lean, root cause analysis, so these process improvement methods into process mining. So I think the combination works very well and is really important, but I'm wondering, do you have any examples or any comments on this?
Yeah, I think that it's an incredibly powerful combination of using improvement methods and the insights from process mining. So I think a lot of improvement methods already incorporate a strong empirical element, right? That you look at Six Sigma, which is all about gathering data and measuring deviations, for example, and doing statistical analysis. I think what process mining adds to in the repertoire of data analysis techniques is that it is so strongly process focused, right? Mm-hmm. So when you have process improvement methods, often you will formulate targets which concern the entire process and not a particular step or a particular action by a participant. So to understand the effects on the overall process performance, it is something that actually only process mining techniques can really provide. You have to do so much work to combine all the data at the individual steps and individual actions to turn into sort of an aggregate value of the performance of a process.
Yeah.
Where process mining tools generate these insights, as let's say the main thing they do. Right. That's a very powerful combination, and I think that the way we talked also about system development, that's the same about improvement projects. It is also, I think, unrealistic to expect that you can think through the best improvements or the most effective improvements completely from behind your desk. So it will often be a situation where you're going to iterate, right? You're going to try a measure, and perhaps you're going to try it in one place while you leave the original situation going on in another place. You will see for quite some time how effective this is. You will compare this with process mining analyses, and then you will take a next step. So this iterative approach where you will redesign, measure, reconsider, redesign, etc. This is something which I think is becomes even more effective when you are using these process mining tools.
Yeah, no, absolutely, yes. So I think that what you just said, that's really important to be able to look at the full process, the end-to-end process, right? That you're not running the risk of optimizing just a subset of the process, and then, you might be not getting the best result. But also, I think traditionally, in the classic way, people go and measure manually by observing people, collecting data, and not using the data from the IT systems that's already there. And you can, of course, one of the concerns is always data quality. We will again come back to this a little bit more. But you can validate the data, and you can test the quality and make sure that it has sufficient quality to do the analysis. And then you're exactly coming to this last point that you made, that you can make these kind of iterative reanalysis really quickly, which you wouldn't be able to do if you had to manually observe again for month and month, what people do.
Not at all. And perhaps one thing that I want to add is with what you get with process mining analysis is, of course, is that you incorporate a number of metrics about the process. So you started the cafe today with a reflection on utilization. So I think it is very important. So I think that whenever you improve a process, I have also some empirical evidence for it. You will win some and you will lose some, right? You will perhaps improve the speed of the process, but it will become less flexible, for example, or you will improve the quality of the process. And the outcomes, but you will slow it down because you introduce a couple of checks. So what I think is important for every improvement program is that you have a sort of a main objective, the things that you want to improve. These process mining tools also help you to keep an eye on the other performance aspects, how they are being affected. And once again, if you have to set up an entirely new measurement program for all these additional things, you won't do it. So that means you are partly blind for the side effects of your process improvement plan or project.
Absolutely, these unintended side effects that can come out. Absolutely, that's such a good point. And maybe one other last note on this, we can also turn it around, right? I think there's a lot that process mining brings to the table for Lean Six Sigma practitioners who are not using process mining today, and that's what we have been just talking about the past few minutes here. But the other way around is also true. And what you see is that as a process mining analyst, when you analyze the process, when you look at the process maps, you look at the statistics, the discovered process map itself, it does not do anything yet, right? You have to do something with these insights to actually achieve a benefit for the process, to make it more efficient, faster, improve the quality, whatever the goal of the process improvement should be. And so existing methods like business process management, but also Lean Six Sigma, theory of constraints, these are methodologies that can be used around process mining to drive the interpretation, to interpret what you're seeing, and to draw the right conclusions from it. And you need some methodology around it. So process mining itself is agnostic to which kind of methodology you use, but you need something around it. And I think Lean Six Sigma is an excellent companion for that.
Yeah, I really like that observation. I think that we have, as a research community, we have progressed so much in the development of process mining techniques, process mining analyses. I think some of my colleagues also expect that we, as a community of computer scientists, will also now do the automatic improvement of processes. I'm not so optimistic in this sense. I think it's much better to look for a combination of, let's say, the tools and the things we develop in the computer science community with more the managerial methods or design thinking from other disciplines, and to blend these things together to make a step from analysis to design and improvement. So it's often the blend of different techniques and the different tools that you can really make an impact.
Yes, I completely agree. You really need a person, a human being who has access to the domain knowledge, so they know the process behind it, but then also understands process improvement methods and process mining to combine all of these insights into the right action. Yes, I completely agree. So I also wanted to talk a little bit about, we're talking already about Lean Six Sigma, which is like a practitioner method that's very successful, used in many companies today, and process mining is, I think, interesting because it came out of the research world, right? So it started around 99, 98, 2000, so it's more or less 20 years old, and in the beginning it was a pure research topic. Now, since 10 years or so, it has been in practical use, and more companies are adopting it. And so sometimes I also see that practitioners who are working at companies, for example, as a process improvement expert, or a Lean Six Sigma black belt, or different roles, or an auditor, right? Or maybe they're responsible for a process as a process manager. Sometimes they're also confused, like how much of the research they need to know to be able to use process mining. And what I always tell them is that they don't have to understand, the algorithms in detail behind it. So, for example, I always tell them it's really a really good idea to, for example, sign up for the MOOC and do the MOOC on Coursera, the process mining course provided by Wilf van Aalst.
Yes,
and it's a really good course, and a lot of practitioners like it a lot also, but some of them, maybe after half of the lectures or so, it becomes very theoretical or mathematical. Maybe they cannot follow through. And what I'm always trying to tell them is they shouldn't feel bad about if that's the case, because in practice there's actually different topics that are important to be able to use process mining in practice. For example, how to detect data quality problems, right? How to clean them, how to interpret the results that you get in the right way. And this is, for example, what we focus on in our trainings, but also in our process mining in practice book that we're putting together. So I do think that as a practitioner, you don't have to understand PetriNet theory in detail behind. Do you agree, or how do you think?
I do agree. I actually appreciated that practitioners wonder about what's going on in the research community. I've always, at least mentally, I've always been a little bit in the middle. I've always been in the middle of, I have worked as a consultant for a number of years in practice. I like practical problems, but I've worked now for even longer in academia and in university. And of course, there I'm used to working on new techniques, new algorithms, new methods. But I like the middle area, and it is interesting if people from one side want to look into the other. I think this is very beneficial, and I think this is also something that we want to foster, perhaps even a little bit more, by bringing these communities together. So there is now we have had this new scientific conference on process mining, which is also has an industry day, for example, where people from industry and researchers are meeting together. And of course, they will not talk about PetriNet theory most of the time. But that is, I think, a very nice event where researchers can at least understand practical issues and also can disclose some of the developments in the research community. And I really believe in these kind of events. For a number of years in Eindhoven, we had the BPM Roundtable, which is a similar event where we on an afternoon had practitioners and researchers meet together. Practitioners would present on results they achieved in industry or challenges they saw, and researchers would show the newest kind of research, but in a way that there was actually a meaningful interaction. So I appreciate these kind of questions. But I agree that practitioners should not worry about understanding perhaps the fine details of all these methods. And I think researchers should also be humble enough to not pretend that they understand all the organizational context in which process mining is being used. Right. That's another terrain.
Exactly. Yeah. Yes. No. Absolutely. I completely agree. And that's also has also been my experience that it's not necessary, but a lot of the people who work at companies, they are interested in what's going on in the process mining research areas, and whether it's to get a glimpse of what's coming in the future or just in general. So I think that's special, and maybe not the case in any field, that there's this interest in both ways.
And I think as a community, as a research community, I see myself mostly as a researcher. I think we should do more with this interest. We should more engage with practice, exchange ideas. I think it's also very beneficial for young researchers to get involved with real world problems, real world processes, which may inspire them, but which also may lead to practical contributions from their research. So I think as a research community, we can also take further steps to get this interaction going.
Yes.
Yeah.
Okay. Now, also maybe just right now, because we also thought that here today in this cafe session, we know there are some people who are interested in process mining research, even though they're working, in they're practitioners working in companies. So we thought, let's maybe also give a glimpse of some of the process mining research that was being done this year. Of course, it would be a very daunting task to try to give a complete summary. There's a lot of things going on. There's this new process mining conference, the International Process Mining Conference that you mentioned, that has taken place this year for the second time, but also still the BPM conference, which was the primary process mining conference, is still going on, and there's still process mining research published there, and there's various other conferences too, and lots of journals, of course. So so we don't want to even try to make kind of a summary or be complete in any way, but each of us picked one paper that we thought we tried to summarize in a very simple way, just to give a glimpse for the practitioners that we just mentioned, who are interested in process mining research. And so should we get into these two example papers that we picked?
Yeah.
Okay, so we have a few slides just as a visual representation. Let me see. Don't think they're visible yet. Let me just share again.
Yeah, it's coming up.
I think now it's coming up, yes. So the first paper that I picked is a paper that I liked very much at this year's Process Mining Conference, International Process Mining Conference. And it's a paper where you're also a co-author, and it was also authored by Robert Verhamer and Arthur de Hofstede. And what I find interesting about the paper is that it's looking at data quality, but it's trying to provide a framework of thinking about the root causes of potential data quality problems, right? So we are also on our blog and in our process mining book, we have collected in the meantime now a wide range of typical data quality problems and what people can do about them and how they can fix them. But I think this is a really interesting way of thinking about, what's behind what's the reason behind this data quality problem? And the idea, of course, then is that it can help to ultimately address these root causes. If you understand better what the reason is, you can address this in a better way. And now the framework itself, it's shown here. It's maybe a little bit small, but we try to give two examples for how different spheres essentially can work together to produce data quality problems. And the first one,
spheres. I like the word of spheres because there's indeed in this model, it looks more daunting than it really is. It looks more complex than it really is. It says when you look for these, when you have data quality problems or potential problems, there are at least three different perspectives that can help you to discover these causes, and those are the spheres that you mentioned: the social, the material, and the personal spheres, and they interact with each other. But you were about to give an example.
Yes,
so go ahead.
Exactly. Just to make it a little bit more concrete. So, for example, the social sphere, that's more or less the organizational context, but also culture, everything. Yeah, that's influencing, and I don't actually know what inculcates means, but let's say it influences the person, right, who's performing the process. So here, the process participant, that's an example like where the process participant is causing a data quality problem by behaving in a different way in the process. And so one example that I could think of is coming from the call center space, where we have seen this with a company quite a few years ago, but it's common in call center environments that people working there are measured based on a metric called first call resolution rate. So first call resolution rate then means or reflects the desire of the company or the customer service department to close a new customer request as quickly as possible and to resolve these problems, right? You don't want to keep them open and you want to solve the problem for the customer very quickly. But ultimately, what this means is that because this is how the performance is measured and this is how the people are being measured who work there, they have a tendency to actually close cases before the problem is solved. And when the customer calls again, they just open a new case, which is then counted as a new issue that was resolved very quickly. So it's a data quality problem because then they changed the way the process works. They are making multiple cases for the same issue, for the same customer. The customer actually has a bad experience because every time they call, they have to completely explain again what the problem was. Yeah. And also in the data, when you analyze it, you get completely the wrong idea about what's happening, and it's influenced by this social.
The social and organizational context,
yes,
indeed.
Yes, and you had another example also in the same line.
We had this is showing this example. This is an example that my Australian colleagues told me about. So in the past years in Australia, there has been new performance indicators for emergency departments within hospitals. So what has happened is that hospitals throughout Australia are now evaluated with respect to meeting a deadline of 4 hours, a maximum of 4 hours of stay of patients in emergency departments. So what happened when this measure was introduced, and you can see that here, so in 2012 that measure was introduced, that this 4-hour boundary was used to assess the performance of emergency departments. You can see one thing which is really obvious. You can see that these hospitals really tried to finish and to transfer patients before this timeline. You can see that because the graph goes up there. But what you cannot see in this data is that the hospitals in the background did something else. They created a new type of room. I think it's called the short stay room, and physically in these hospitals, short stay rooms were physically emergency department rooms. They were just next to the room, and people were transferred on paper from this emergency room to the short stay room, but they didn't go anywhere. They were just simply in the same setting. And there was a new activity in the process which said move patient from emergency department to the short stay room. So here, when you just look at the data, you see all kinds of new activities and you see new kinds of durations and new kinds of steps. But the process hasn't changed. The process has, the recording has actually changed, which if you're not aware of these kind of changes in the organizational context or even the national context, the change of this data doesn't make any sense. It only starts making sense when you understand what people are trying to achieve on paper. Only by realizing this, you understand that the people who are in this short stay room should still be considered as people who are undergoing emergency treatment.
Yes, and the process itself has not improved, right? It has gotten worse, I think. It sounds like. It's gotten
worse, of course. Yeah. There's more administration, the more recordings. And it requires, and that is, I think, the idea behind this framework and this paper is it requires an understanding of these contextual factors to make sense of the data.
Yeah. Yes. And I think that's also something that, for example, an experienced process improvement practitioners, right? They're trained to look for incentives and cultural aspects around the process to capture such influences. So that's also captured by the framework.
So we also try to warn our students that by just looking at the data, you cannot get the full picture, right? If you have no understanding of these contextual things, the data doesn't make any sense for you, and also the analysis doesn't make any sense.
Yeah, exactly. Yeah. So I think that's an important dimension, like where the root causes lie. So ultimately, you actually have to look at this incentive structure and maybe the measurements, to really solve this. As a second and last example for this framework, I also picked one from the IT side. So the material sphere here stands for how the IT systems that support the process influence the way that people work with it. And so the one example that I could think of here was in a process where in a credit application process. So customers were requesting loans or credit, applied for credit with a financial company, and then the system itself did not have a particular functionality, and people then worked around the system by misusing essentially a different kind of status that was indicating some kind of incomplete. For example, if the application, if someone applies for this loan and they have not submitted all the papers that are necessary to complete the application, the status would be set to incomplete. And they were misusing this incomplete status just to delay payouts for loans that should be paid out on a particular day of the month. So, of course, this is also a data quality problem, because then when you're looking at the data, it looks like a lot of the applications are incomplete, where they're actually not. It's just the way that people work around a missing feature in the IT system to get it right. So,
and it's a great example, because it shows also how creative people are. It shows how people will use or misuse the system so that it conforms to their work practices, and not the ideas of the system developer or the management behind that system.
Yes. Exactly.
Yeah.
Okay, so
it also reminds me, by the way, to the question that we had at the start of this session about this logging of timestamps, so that you would perhaps consider asking people to log, in addition to the work they do, at the time they would start a work item, so that you could do a more detailed analysis, process mining analysis later on. So this reminds me of that if your IT system, and it's again an example of how the material world influences participants so that you get data quality issues. If you require people to manually log timestamps in systems without supporting them to do that in the proper format or to correct mistakes automatically, this is asking for so much issues, right? People will use different data formats. People will order the years and the months, the years and the days differently, etc. And then again, you can see this as another example of where the material world, so the IT support, will influence people in creating data quality issues.
Yes, and you can scream at them to not make any mistakes, but that's not reasonable. So, right.
No.
Okay, so that's the one paper that I picked, and you picked a different one. Do you want to tell us what this is about?
Yeah, so the previous paper was presented at the Process Mining Conference, the International Process Mining Conference, and this is a paper that I picked, and it's not without any bias, because it's a paper that shows the main research ideas behind the PhD project that is executed by Jelmer Korn. Jelmer is a PhD student in my group in Utrecht. And he is working together with a healthcare organization, and more general. So the healthcare organization has the following issue or the following managerial consideration, that in many situations you can take different, when something happens, you can take different actions. There was an event, for example, you can see that a patient with mental issues becomes aggressive, and you can do different things. You can start talking with the patient, or you can medicate the patient, or you can isolate the patient, and these are more or less alternatives to each other. But what is really interesting is to understand when these different actions or different responses to what kind of effects they lead. So let's suppose that talking is actually more effective than isolating the patients, then this is something that you want to learn from the data. And what Jelmer, together with Cici Lu and Henrik, I've also been involved, what we have been working on is to look within processes for these kind of mini patterns where you say, there's an event, there's an action, there's a response, and can we now determine what the most effective responses are in particular situations?
Yeah, so you have been looking at it in the process itself, right?
Yeah, in the process. So these are mini patterns within processes that we analyzed, and we developed techniques to understand these effects better.
Yeah, so let's try to bring up the visual for that. It's not having a delay. Let me just share again. Mm-hmm. So now you should see the. Yeah.
So this is a sort of a, everybody will recognize this who knows a little bit about process mining. So we first discover the process, and when you look at this model, you will see that we have classified the different activities in this process into the different categories. So you can see that there is an action which takes place, and you can see that at the top of the graph. So there's physical aggression, for example, in a sort of a ward for mentally challenged people, and then you can see different responses. For example, talk to the client, or talk to the client, but also walk away from the client so that you are becoming safe. And then there are also different effects. For example, that the client starts throwing with things, which is physical aggression, right? It starts to work on objects, or attacking people, or verbal aggression. And these things are effects. So when you have a sort of a process understanding, you can start labeling the things which have a causal relation to each other. This happens, this is what we try to do, and this is the effect, what takes place. So once you have that insight, maybe it's good to move to the next visualization. Then we can generate, and this is the technique that we describe in this paper, that you can generate these kind of trees where you can see there is an action, there is a response, and then there is an effect. Those are the three layers that you can see in this graph. And the thick arrows and the small, the more narrow arrows indicate whether something happens more often than you would expect. And if something happens more often than you would expect just by matter of chance, it means that there is a causal effect. So what you can see here is that the terminating the contact is leading to a desired outcome in many more occasions than you would expect just by mere chance. So this terminating contact in this physical aggression situation is a very effective response. Other actions, it would go too far to explain the whole tree, but other actions are perhaps much less effective. So what you get from this is, on top of an understanding of the process, you get to understand the mini patterns of causality. I do this, then this happens, and this is much more effective than doing it in this way. So this gives you a sort of an additional layer of explanation of what is happening in your process, which you can use, of course, to also change your process, to instruct, for example, your nurses to take some actions or to do some responses rather than others, because the data shows that is more effective if you want to have desired outcomes.
Yes, that's so interesting. I think it's a really nice example how you can combine different fields in the whole process mining research area, right? So, for example, here you make use of statistical techniques and you combine it with with this analysis. And I think that's one of the reasons why that's such a great area of research. There's still so many topics that can be explored and combined, and you can leverage techniques together.
I'm very enthusiastic about this because I think now we get to see that many people in industry are also getting interested in process mining. I think in a couple of years we can also help them to not just understand the order of things, but also the causality between these things. It's not just that this happened after this has happened. No, it is very likely that this would happen because this previous action is trying to achieve this particular result, right? And also when you see alternatives, you can say, oh, this alternative path is actually much more effective than the other one.
Yes.
So we will get these additional layers of insights built on top of the process model.
Yeah, to show, for example, correlations like this.
Absolutely.
Yes, absolutely. That's great. Thanks for sharing that. We will, together when we send the recording sometime next week or so, we will also share the links to the two papers. So for those of you who want to dive into it in more detail, you can read it then. But yeah, so I think that's it's a nice These were, I think, two nice examples that show that what is going on the research side definitely is also relevant for practitioners. And yeah, you already mentioned that the industry day is a good way also for researchers and practitioners to connect. You are in charge of the industry day at the Process Mining Conference next year, isn't this correct?
Yes, yeah, that is correct. So I'm very glad also to use this opportunity to announce that the International Conference on Process Mining will take place in the Netherlands in 2021. Let's hope that it's going to be a physical event, but I'm pretty optimistic about this. And indeed, we are organizing as part of that conference an industry day where we are thinking of having activities where practitioners and researchers get together, where practitioners can hear more about the newest developments in research. And on the other hand, where researchers can learn from practitioners what are really the challenging situations, the kind of analysis questions that occur. So I invite everyone who is around, and I know there's a big base of followers of Fluxicon, of course, also in the Netherlands, but also in Germany and Belgium, and Eindhoven is really well situated for this, to attend that day, when they want to learn more about process mining and to get involved in research.
Yes, exactly. No, that's definitely something that we all look forward to. So that will be a nice point next year in November, I think, right? It's taking place.
Yes.
So still lots of time, but maybe even outside of the specific industry day and the conference, I think in general some people also practitioners might be wondering how they can work together with researchers in different ways. And so I think one cooperation area is joint research projects where they're supporting a full PhD student or postdoc, but also there are smaller areas, like for example working together with a master student. And so one thing that I see also is when I talk to practitioners, I also try to explain to them that they should not have the wrong expectations about this, right? So for example, a master student shouldn't be a way, just like a cheap or free way to do like a process mining project for them, because they have to realize that often the students, they definitely don't have the domain knowledge for the processes. So they're also new to the topics, so they have time, but even in the time of the project, they can never get into the depth as much as someone who's working at the company could be. So they do need supervision. So it does take time to supervise them properly and work with them. But at the same time, it can be a really good way to collaborate. So I was wondering, do you have any tips for practitioners who are interested in that, what they maybe should think of, or how they find a student who could work with them?
So it's a nice what I would say coincidence that only yesterday I received an email by a former student in one of my classes in Eindhoven, who's now working with a company. He said, I saw the announcement that you're also participating in this Process Cafe. By the way, my organization is really looking for a student to work on a particular problem that we have. Can you take a look at it, whether this is perhaps suitable for a master project? I think that is a very nice way of doing it. I think there are many groups in the Netherlands who would be open to work together with organizations to formulate projects for their students. So I would say, have a look at, that would be my recommendations for practitioners, have a look at your network, at your contacts, at the different universities that you work with, And I think most researchers will be very open to being contacted about the formulation of master projects. I think there are many benefits to this for the students in particular. For students, it is fantastic to really get involved in real projects and to see real challenges there. For researchers, it is really a nice way also to test new approaches or to test new ideas in practice. And indeed, especially for organizations who are not so familiar with process mining or don't know how to start with it, it could be a good way to get started. I must emphasize that you should have the right expectations. Students are not cheap consultants who will do dirty work or things that will that you would that are very labor intensive perhaps, but have very little intellectual depth. Students have to also develop new things. So I would rather see a cooperation via student as a way to cooperate in a particular area and to learn more than to really solve perhaps the most pressing problems that you have within an organization. But with this mindset, I think it's a very nice low barrier way of working together.
Yes, exactly. I completely agree. And unfortunately, there's not one that I know of, any kind of marketplace or something where, let's say, students looking for internships or projects and companies can find each other.
No, not on a national level, but for example, if I speak for Utrecht University, we have this sort of a platform, Conjoin, where we indeed announce new project proposals, and there's a sort of a matching between at least the students and supervisors. But of course, the organizations need to either contact students or the supervisors to also express what they have in terms of projects.
Right, exactly. Yeah, this really is different for each university. So it's good that you have this type of platform, because not every university has it, even internally. Good. But what I also wanted to offer to the practitioners watching this here today and who are interested in having some student cooperations. So we have our academic program where we support universities. More than 700 universities worldwide working, with process mining in our academic partnership program. And so we have contact persons at these universities. So if you are interested in finding a student, that's also something that we can facilitate. So for example, Hajo is our contact person for Utrecht University. So if someone is interested in a master student, I would let him know, and he can then share this on this platform that he just mentioned. And we can do the same thing with other partner universities. So if you're interested, don't hesitate, and just let us know about it, and we'll see if we can help.
Yeah, very nice.
So let me just see whether there's more questions or comments in the chat. So for example, Jeroen was saying that he's using process mining he wants to use process mining to explain the process and to build a machine learning model to predict special outcomes in the process, and what you would advice for that. I think actually the example that you gave is a nice example, right, where you're looking into statistics. But do you have any more tips, like papers in this direction that you should?
I don't know them by heart, but there are already quite some approaches in our field where this has been tried. So we already have quite some understanding of which techniques work well. It also depends on the kind of data that is, of course, available. So I could give some pointers. I know, for example, Sebastian van Zelst in Aachen has worked on this topic. Also in the recent Process Mining Conference, I've seen some work there. I'm not an expert in this field, but I know that the combination of machine learning and process mining to predict process outcomes is a hot topic in our research field. There's actually quite some work going on there. So perhaps I should give you some pointers, Anna, which you can make available.
We can check, but also just in general, I think I can see the question was asked like what the names of these two conferences were that we mentioned. So one of them is it's ICPM, so it stands for International Conference for Process Mining, that has been taking place for 2 years now, the second time this year, and before the other conference we mentioned was the BPM conference, so Business Process Management Conference. So if you're looking at these conferences and the workshops around it, then if you're looking at the publications of the past years, you will that's a good way also to get an overview about what current research is about if you're a researcher who want to dive into these topics in more detail and see what people are working on. I think that's a really good starting point.
Yeah. So the BPM conference of next year will take place in Rome. So everybody who knows me also knows that I really hope that this conference will go through. Rome is my favorite city to visit. So if you Google for BPM 2021 Rome, you will also find that links to that website and to the different events which are organized around it.
Yes. Okay, great. Well, maybe as a last question to you, Hajo, before we have to go, can you give us a little bit of a glimpse of the research that you're working on within your team right now? Is there anything specific that you're specifically excited about, or can you share something with us?
Yes, thanks for asking, because I'm really excited about a field that we are working on with different people, in particular Inge van der Weert and Iris Berenpoot, who are working in my group in Utrecht, and they work on the topic of workaround mining. So what that means is to find out, mostly through process mining techniques, but also additional techniques like observation of people and interviewing people, to find out how people work with, but also around information systems. So our particular focus at the moment is healthcare. Iris, for example, has looked at maybe 10 different hospitals and medical institutes, how people work with electronic health records and information systems, and created a complete taxonomy of what may happen. What may happen when people are confronted with a rigid IT system and when they have to perform their work. But the dream of this research stream is that you don't have to follow professionals, nurses, doctors, or professionals in other kind of settings all the time by looking what they're doing, but that you can learn from data in the same way as process mining is doing this, that you can learn from data that is left behind by people using all kinds of IT systems, how they work with or work around the system. So, for example, this morning I read in the newspaper that a nurse in Den Bosch, that's the city where I live, is now has given medication to a patient in a situation where the anesthetist was not available. And even though was not allowed to do this, she had to do something with the patient which was there. But the IT system prevented it from doing it, but she did it anyway. So this is a typical situation that happens in a healthcare setting. Something has to happen, but the system doesn't allow it. What the dream of this approach is to see what happens and what is different from what the prescribed or normative process is, to identify this, and then it becomes interesting to also take actions, because you can say, well, we can do different things. We can perhaps the workaround item that we found is an indication that the original system was not properly designed. Then we have to fix the system. But you can also find out that the way people work around the system is actually very undesirable, and then you want to prevent people from doing it. Or you can say, well, sometimes people do things which are not exactly as we expected, but we ignore it. But you can take a range of actions. So we see this not only as a negative research line, in the sense that we want to prevent people from doing things, but also as a positive thing. As soon as we see people work around the system, this is also often an opportunity to improve things. And I think this whole research line has a lot of potential, and it also shows a sort of a natural progression of how our process mining field evolves. It's not only about analysis; it's also about the follow-up. what are we going to do with these things? And it's exactly, I think, what I'm excited about. It's about combining computer science techniques with organizational measures, organizational improvement, and probably in tight combination with each other. So that is, everybody who wants to know more about this, I invite them to contact me, and I'll get you in touch with our main researchers, with Inge and with Iris, because I think this is a theme which we will only develop over the next years to come.
Very, very interesting, and it's nicely closing the loop, right? Bringing us back to where we started, the techniques themselves, the systems, but also the people who work in them and who always will find workarounds if the system doesn't work the way that they need it. And we have to deal with this in a reasonable way, and not by blaming people. Or you have to really take a wide view and look at everything to make good decisions with this.
Nicely put.
Oh, very, very nice. Thanks so much, Hajo. It's always a pleasure to talk to you. It was really nice to talk to you today. So very nice to have you as a guest.
It was a pleasure.
And I think we have given quite some pointers also to people, who are maybe some ideas that they can think about, and if not, then a glimpse of what's going on the research side in the process mining area. Yes, if you have any more questions or comments about today's show, you can also just send us an email. You can send it to cafe@fluxicon.com. We will share the recording maybe in a week or so you will see it on the blog or on the mailing list. So you can watch it back later if you maybe missed the beginning of it. And so thanks again, Hajo. Thank all of you who joined here today. We will be back with another session in January, on 19th January, where we will talk about process mining and customer journeys. So until then, thanks a lot, and have a good holidays and good end of the year.